So my name is KISLAY Kumar and I'm from Department CSE. So today we're gonna talk about the topic, the pigeonhole principle. First, we'll see the background of the pigeonhole principle. So the pigeonhole principle is one of the most elementary yet surprisingly powerful tools in mathematics, especially in the field of combinatorics. Through simple statement, it provides deep insights into problems involving counting and distribution. At its core, the principle reveals that if more items are placed into fewer containers, some containers must hold more than one item. This idea underpins a wide range of logical argument and proofs, from birthday paradoxes to computer hashing algorithms. This presentation explores the concept, applications, and significance of the pigeonhole principle across disciplines. So now we'll see the overview of the pigeonhole principle. In this presentation, we will explore the pigeonhole principle, a fundamental concept in combinatorics and that demonstrate how constraints on placements can lead to guaranteed outcomes. We will begin with the basic definition and intuitive examples, then move on to formal statements and generalizations. We'll examine real-world and mathematical applications followed by example problems to illustrate its practical use. Finally, we will discuss its limitation and conclude with a summary and open questions. Introduction. The pigeonhole principle is a simple yet powerful idea in mathematics. It states if n plus 1, n plus 1, n plus 1 or more objects are placed into n containers, then at least one container must contain more than one subject. Useful in proofs and problem solving in discrete math, computer science, and real life. So we'll see the definition of pigeonhole principle, which is the pigeonhole principle is a basic concept in combinatorics that states if more items are placed into fewer containers, at least one container must contain more than one item. So now we'll see one example problem based on pigeonhole principle. So this is the problem statement that show that in any group of 367 people, at least two people must share the same birthday. So here's the explanation. There are 366 possible birthdays, including February 29 in a leap year. We are placing 367 people into 366 birthday slots. So by the pigeonhole principle, if you place more item people than containers, at least one container must contain more than one item. Therefore, at least two people share the same birthday. Now we'll see the formal statement of the pigeonhole principle. The pigeonhole principle can formally stated into two ways: the basic form and the general form. Gen- the basic form states that if more than n items are placed into n containers, then at least one container must hold more than one item. In other words, if you have k plus 1 or more objects and only k boxes to place them in, at least one box will contain at least two objects. The general form extends this idea. If n objects are placed into k boxes, then at least one box will contain at least n by k objects, where bracket denotes the ceiling function, which means we round up to nearest whole number. The stronger version is especially useful in problems where we want to determine not just the presence of repetition but a minimal number of items in a single category. Both forms are widely used in mathematical proofs and problem solving. So, pigeonhole principle has some limitations, or we can say drawbacks also. So, let's see the limitations of the pigeonhole principle. While the pigeonhole principle is a powerful tool, it has some important limitations. It is a non-constructive method, meaning it only guarantees the existence of a repetition or overlap, but does not identify which team is repeated or where the repetition occurs. The basic form of the principle provides no quantitative insight beyond the fact that duplication must happen. It doesn't tell us how many repetitions are there are or in which specific category. Additionally, without applying the general or strong forms, the principle may not be useful for more complex or detailed distribution problems. In high-level mathematical or abstract application, the principle effectively may require additional reasoning or tools. Despite these limitations, it remains a fundamental and widely used technique in mathematics, computer science, and logic. So, we came down to the conclusion part. The pigeonhole principle is a simple yet powerful concept that illustrates how limitations in space or categories inevitably lead to repetition or overlap. Though it may appear trivial at first glance, its applications span a wide range of fields, including mathematics, computer science, and everyday logic. By guaranteeing the existence of certain outcomes, it serves as a fundamental tool in providing results and solving problems. Whether it's detecting data collisions, analyzing birthday scenarios, or ensuring distribution fairness, the principle demonstrates how basic reasoning can lead us to strong conclusions. Understanding its length and limitations helps us in appreciate its role in both theoretical and practical concepts. Thank you guys for watching my video. So if you guys have any question, please comment down and I'll make sure to answer each and everyone's question as soon as possible. I know that I have posted this video after a long time, but I'll assure you that the videos will be coming as soon as we got assignments and video assignments from the college. Thank you guys for watching my video. Thank you.